Hello everyone, welcome back to this another video by Map Mentors. My name is Lalit. Today we are going to learn about the outliers and how can we deal with the outliers using the R software. So let's start with the definition. So what are outliers? So outliers are those extreme data points that are significantly different from the rest of the data set. So they lie far away from the majority of the observation and can either be much higher or lower than the expected value. For example, you can see in this scatter plot. So these data in the with the blue dots, they are the normal data, and one with the red, they are the outliers because they are not following the pattern. Rather, they are going extremely low and extremely high. So such points are called the outliers. While doing the data analysis, we must consider those outliers because they can significantly affect our outcome and draw the wrong interpretation and outcome from to those data. So why do outlier exist in the data? There might be several reasons. I have listed few of them. For example, it might be due to natural variability or maybe errors while doing a measurement or recording the data. So data processing error. This might be due to fraud or anomalous event, a sampling issue, and many more. So how do you detect the outliers? So there are different type of method to detect the outlier, but the most common methods are using the Z-score, that is standard deviation method, interquartile range method, and using the box plot. So in this video, we are going to explore how can we detect the outlier using box plot and IQR method. Let's go to the coding section. So this is my R Studio. I have already prepared some data set. So let me import the data set. First, I'm going to make a section like this. So I'm defining a variable called df. Then I'm going to write this code to import the dataset. So read.csv, my file format is in CSV. That's why I'm writing read.csv. So let me hit tab. So once I hit tab, it will show all the datasets that are in my directory. So I have the dataset in this dataset.csv. Let me run this. So I want to see the dataset. So I'm going to use this function called head, right? So you can see that I have treatment, replication, plant height, grain yield, leaf area, chlorophyll, biomass, root length, and many more variable are here. So I'm going to create one box plot to see if there are outliers in my data set or not. So inside the box plot, I'm going to select this, okay, this variable called root length because I know there are some outliers in the root length, and I'm going to select this treatment. Okay, treatment is not found. So let me change the code, right? So you can see that there are a lot of outliers in treatment and root lengths. So in treatment one, there are one, two, three outliers, and in treatment two, there are also three outliers in the variable. So we are going to identify those outlier and replace those outliers with the mean, right? So once we know that outlier exists in our data set, so then we need to calculate the IQR method. So IQR method, as we all know that it's the interquartile range. So IQR interquartile range method. So IQR stands for interquartile range, and the formula to calculate IQR is third quartile minus first quartile, right? So we need to find the first quartile. So I'm doing first quartile as Q1, and the formula is quantile df dollar root length, right? And first quartile is 0.25 percentile, right? Let me run this, and Q3 is my quantile df dollar root length, and third quartile is 0.75%, right? So let me run this. Now it will give us the output of IQR. So formula for IQR, IQR is, as we know, that Q3 minus Q1, right? Let me state the formula and print the value for IQR, right? So the IQR value is 3.51. Since we have Q3, Q1, and IQR value, now we can find out the outliers right? So let me show this presentation once again. So in IQR method, we need to find the minimum and maximum. And if the value is below the minimum, that will consider as outlier. And if the value is above the maximum, that will also consider outlier. So minimum maximum, the formula is for the minimum is Q1 minus 1.5 into IQR, and for the maximum Q3 plus 1.5 into IQR. So let's set this formula. I'm going to make a variable called lower bound for minimum. So lower bound, for the lower bound, our formula is Q1 minus 1.5 into IQR, right? So Q1 minus 1.5 into IQR. Okay. So let me print this lower bound, right? So the value that are lesser than 16.83 will be considered as outlier, and for the maximum I'm going to use this upper bound variable, and I'm going to set the formula is Q3 plus 1.5 into IQR, right? And let me print this upper bound, right? So upper bound is 30.89. All right, then let's set a logic to find the IQR. So our logic is that if our value is less than Q1, or our value is greater than Q3, will be considered as outlier, right? So let me make a variable with the name outlier, and I'm going to set this logic here, like df dollar root length. If it's less than IQR, uh, sorry. So if it's less than a lower bound, or df dollar root length if it's greater than upper bound, right? So these are this will be considered as the outlier. Let me run this, right? So let me print uh, out outlier. So this will give us the boolean value. Here are most of these value are false, 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 and some are true. So the values that it gives us true, that these are our outliers. So here let me make one variable called outlier value, and if our df dollar, so I'm going in the outlier values, I'm going to select all the values that are outlier here. So outliers, right? So let me print those outlier values, right? So we have the outlier values 105, 90, 31, 100, and 95. So if we check our upper bound and lower bound, you can see that our lower bound is the value for the lower bound is 16.83 and upper bound is 30. So all the values that are lower than 16 and higher than 30s are called our outliers, and you can see all the values are here upper than 30. So these are the outliers. 1, 2, 3, 4, 5, right? There are five values that are outlier. And if we again check, like if we again make a box plot df dollar root length, you can see we have the five outliers: 1, 2, 3, 4, 5 outliers, which are all above the upper bound. So we can see that the values are above 30, not below the 16. So these all are the outliers. So thank you for watching this video. We have completed how to identify the outliers in our data. In our next video, we are going to explore how to manage these outlier, where there are different techniques. Either we can replace them or we can transform. So thank you so much for watching this video. I'll see you next time.